When we talk about work in thermodynamics, we are not only talking about the applied force or moving objects. We are talking about how much energy can really be used and how much is lost along the way. The interesting part is that two processes that start and end in the same way can give very different results. To understand why, we need to talk about three key ideas: maximum work, reversible work, and irreversibility. Maximum work is the greatest amount of work a system can produce under ideal conditions. It is important to say this from the beginning. It's a theoretical limit. It does not describe what usually happens, but what could happen in the best possible case. To reach maximum work, the process will need to occur without friction, without energy losses, and in a perfect controlled way. In other words, in an ideal world. This concept is important because maximum work is used as a reference. It allows you to compare how much work we lose when we move from the ideal world to real process. For example, when we move the plunger of a swing slowly, the motion is smooth and controlled. The more control we have, the closer we are to maximum work. If we move it quickly, energy losses appear and the useful work is reduced. So, to understand maximum work, we first need to talk about reversible work. A reversible process is one that happens so slowly that the system stays in equilibrium at all times. It is so slow that it could be reserved exactly, without leaving change in the system or its surroundings. If something happens too fast, it is not longer reversible. For this reason, reversible processes do not exist perfectly in a real life, but they can be approximated. And here is the key idea: every reversible process produces the maximum possible work. Experiment. When we compress and expand slowly, the system can return to the original state. When the motion is sudden, it is not longer possible to go back in the same way. Now we arrive at what is unavoidable inversibility. Every real process is irreversible. Effects such as friction, heat losses, impacts, and turbulence will appear. So, when we rub our hands together, mechanical energy quickly turns into heat. This heat cannot spontaneously be converted back into useful work. Each bounce is slower than the previous one. Energy does not disappear, but it spread out can no longer be used as useful work. This loss of ability to produce work is clearly irreversibility. In summary, maximum work is the ideal limit. Reversible work is the perfect path, and irreversibility is what separates the theory from reality. Thermodynamics does not promise perfect process, but it gives us the tools to understand what there are always energy losses.